Hi everyone. Time to get back to it after what I hope was a relaxing spring break for you. I know that you probably didn't get to do everything you wanted to, but I still hope the break was good for you. And today's lesson is double angle formulas. And I have one for sine, one for tangent, and one for cosine. And we're going to just use these in several equations to solve. We're going to use them just to simplify expressions as well. And I've got the sine of 2u, the identity, is equal to 2 sine u cosine u. So you'll need to have these written down. The tangent of 2u is 2 times the tangent of u over 1 minus tangent squared u. And the cosine of 2u is these three things. Cosine squared of u minus sine squared of u. And if we do a little substituting, because sine squared plus cosine squared is 1, and do those and replacing, you would get these other two also. 2 cosine squared u minus 1 and 1 minus 2 sine squared u. You could use whichever one of these might fit best in your situation is what you'll want to use. So we're going to solve equations first. And I've got cosine of 2x equals or plus cosine of x equals 0. And when I look at this, and I see cosine here, I think I want to use the identity that just has cosine in it. So that's what I'm going to do. Cosine of 2x. So I'm going to write 2 cosine squared x minus 1 plus cosine x equals 0. All right? And then I have 2 cosine squared x. I'm going to rearrange this. That's the second power of cosine of x. Here's the first power plus cosine of x. And then here's your constant equals 0. All right, I do want to multiply to negative 2. I want to factor this. So I'm essentially factoring 2 u squared plus u minus 1. And I take the 2 times negative 1. I need two numbers that multiply to negative 1, and then the coefficient of u, the middle term, they need to add to 1. So that's 2 and probably negative 1. 2 times negative 1, 2 plus negative 1. So I got 2u squared plus 2u minus u minus 1 that I'm factoring by grouping. And those first two, factor out the 2 and the u. So I got 2u and u plus 1. The second two, I'm going to subtract, I'm going to take a negative 1 out of each of those, and that's u plus 1. So that's 2u minus 1 times u plus 1. However you get to this, if you just do it like trial and error, however you use to get to this, go ahead, but we need to have that factored. And so what do I have? Instead of u, I have cosine of x. So 2 times cosine of x minus 1 times cosine of x plus 1 equals 0. And then the zero product property says set each one equal to 0, because one of them is 0, if this is true. And let's just solve. So I'm going to add 1 and add 1. I got 2 times the cosine of x plus 1 equals, oops, that canceled, equals 1 divided by 2. So I have cosine of x. Boy, I didn't give myself enough room here. All right, let's find a little bit of room for the unit circle here. And cosine is 1/2. Where would that? That would be right there. Now that would also be right here. So I'm looking at pi over 3. If you're looking at your reacquainting yourselves with your unit circle, and I think you're looking at 5 pi over 3 here. And so the inverse cosine, which I just already kind of talked about, of each side, the inverse cosine of 1/2, that's telling me x is pi over 3 plus 2n pi. Remember that? Because we could go around 2 pi units again as many times. Or 5 pi over 3 plus 2n pi. Now, in addition to that, so I got two of them. There's one, there's two. We got to do this one also. Cosine of x equals negative 1. Well, that's over here, and that's pi. So x equals pi when I take the inverse cosine of both sides. I'll just kind of write that as a formality here. Inverse cosine of this side. X equals pi plus 2n pi. I think that's the way I'll write that one. And there's our third solution. 2, 3 solutions plus all the multiples of that. Those three. Pi over 3, 5 pi over 3, and pi. And then all the other ones that would go off of those. All right. Next, let's solve sine of 4x equals negative 2 sine of 2x. All right. Well, let me do this first. I'm going to write this as sine of 2 times 2x. Okay? And right here, I'm going to write negative 2, and then I'm going to go ahead for sine of 2x, write 2. I'm trying to get it down to just a single thing. 2 sine x cosine x. Using that first identity, replacing sine of 2x with 2 sine cosine x. And on this one, though, I'm going to go the 2, but the sine of 2x cosine 2x equals negative 2, equals negative 4 times the sine of x cosine x. All right, not sure where this is leading. And so we'll stay with it here a little bit. And actually, what I think I want to do, can you tell I didn't work this out yet? I'm going to keep this 2 sine 2x cosine 2x. Now, there's nothing wrong with what we did here, but I'm going to write this as negative 2 because I see an opportunity here to get rid of something. And if I were to divide by the sine of 2x on both sides. Okay, so I'm not going to do this or this right now. We may have been able to get there, but I think I found a way to make this a little shorter. So I've got 2 times the cosine of 2x equals negative 2. Now, I am going to divide by 2, and now I have the cosine of 2x equals negative 1. Okay, I do not remember if we did the multiple angle things. But I am going to show you something, and I may be getting ahead of myself. My only hesitation is I'm not sure we have done this kind of problem before. I'm not going to use any of these identities up here for cosine at this point. I'm going to take the inverse cosine of both sides here. And when I take the inverse cosine, I still have 2x here. The inverse cosine of -1, I think I did that already somewhere, is pi. So 2x equals pi. And then that's pi plus 2 pi n. And then let's just divide everything by 2. And our final answer for x, I'll come up here. Once again, I didn't leave enough room. I'll just keep that in mind when I'm making the next video. Divide by 2 there. Pi over 2, divide both parts by 2, plus pi n is your solution. Okay, right here I solved for the 2x using the inverse cosine and then just divided everything by 2. That's all I did there. And I don't remember if we've done multiplication. I would remember if I hadn't already done it in pre-calc, and that's what's just making me wonder. All right. We are rewriting expressions using double angle formulas. Well, remember, let's see if I can remember. If not, I'll just look at it. That sine of 2u equals 2 sine u cosine u. Now, where are we? Okay. So that's sine of 2u equals 2 sine u cosine u. All right. So let's just replace it with x. Sine of 2x equals 2 sine x cosine x. So what can I do so I have just sine x cosine x? I think I can divide by 2. I'll divide by 2. So I have the sine of 2x over 2. I can't divide that. It's the sine of this angle divided by 2. I have to just leave it like that. Equals the sine of x cosine x. Sine of x cosine x. So this is what that is equal to. Now, number 4, 6 cosine squared x minus 3. Let's just take a look at our identities up here. I think we might be onto something there. So cosine of 2u, oh, gone the wrong way again. Cosine of 2u equals 2 cosine squared u minus 1. So cosine of 2x equals 2 cosine squared x minus 1. So I think to get 6, if I multiply by 3 and I distribute, I'm going to have 3 times cosine of 2x. Again, you can't multiply that 3 by that. It just stays on the outside like this is a variable. You don't put it inside there. Equals 6 cosine squared x minus 3, which is what this is. So here's the identity. This is equal to that. This is equal to that. I hope you saw that. I just had I have a feeling I didn't have that framed very well. So, last thing. We have that the cosine of theta is 5/13. We also have that theta is between 3 pi over 2 and 2 pi. That is over here somewhere. Here's 3 pi over 2. And here's 2 pi. So, we are in this quadrant. The cosine is 5/13. So I'm going to make a triangle. And let me go somewhere like right around here and make this triangle. And let me just kind of, here's my y. My x is 5, that one right here, and my hypotenuse is 13. And I believe that if you use Pythagorean theorem, this is a Pythagorean triple, and that y is 12. But it's negative 12 because it's in this quadrant. So the cosine of theta is 5/13 is 5/13. The sine of theta, that was given, is negative 12/13. Okay, remember this is theta up here. Okay, and the tangent of theta, all right, is sine over cosine, so negative 12/5. Okay, I got to somehow straighten out. What did I do wrong with that angle? That's 5. Oh, wait. This is theta right here, not that. Okay. Theta's not up here. Theta's down here. Because we'd be talking about that angle right there that it makes with the x-axis, and those two would be equivalent because they're alternate interior angles. All right, that's good. Just a little bit of a mishap there. But I stand by that opposite over adjacent, that's tangent. Opposite over hypotenuse there, and adjacent over hypotenuse, the 5/13 we were given. So we have all those values. Now we can use those to find the sine of 2u, well, 2 theta here. We ought to change these to all the thetas here, right? Sine of 2 theta is 2 sine u cosine u, sine theta, cosine theta, and that's 2 times 5, negative, I'll just do it in the right order, 2 times negative 12/13 in the order that we got here, that's a negative, times 5/13. 2 times 5 is 10. 10 times negative 12 is negative 120. That's your numerator. And 13 times 13 is 169. So the sine of 2u is that. Now, which one do we want to use for cosine of 2u, of the ones that we had? Oh, we got them both. We may as well just use them. Cosine squared u minus sine squared u. So cosine of 2 theta is cosine squared theta minus sine squared theta, which in this problem it is 5/13 squared minus negative 12/13 squared. 5 times 5, that's 25 over 169, minus, and the negative times negative is positive, minus 144 over 169. So 25 minus 144, I think, is negative 119 over 169. Boy, those are really close to each other. And then the tangent of 2 theta, I would be tempted just to use sine over cosine, although we could use one of the identities we had here. What do we have for tangent? Ooh. Okay. We do have an identity. The video is getting pretty long, so how about if I just do sine of 2 theta over cosine of 2 theta. That might be a way you want to do this anyway. Although, you could double check this with the identity that's on the other page to see if you come up with this. But sine of 2 theta is negative 120 over 169 over negative 119 over 169. And if I multiply the bottom by 169 to get that to cancel out, and multiply the top by 169. That's also going to cancel out. And it looks like we got negative 120 over negative 119, which is positive 120 over positive 119.